For most of human history, the idea of living on Mars was just science fiction, right? Something for books and movies. But that's all changing. Right now, it's not a question of if we'll get there, but how. We're going to break down the incredible and honestly pretty wild blueprint for making humanity a multi-planetary species. But let's get one thing straight right from the get-go. This is not a done deal. Far from it. The timelines, the technology, the whole philosophy behind it, it's all up for grabs. I mean, just look at this quote from aerospace engineer Robert Zubrin. People are literally betting money on it. The stakes are just unbelievably high, and believe me, opinions are fierce. This is one of the biggest things we've ever tried to do, and everybody has an idea about how it should play out. So, to really get how we're planning to land humans on Mars, you first have to understand this massive shift in strategy that happened, not in space, but right here on Earth. The entire game plan for the Red Planet got a complete overhaul in a shockingly short amount of time. For decades, the big prize, the end goal, was just bringing a few Martian rocks back home. But that program, the Mars Sample Return, started to get bogged down. By 2024, the price tag had just exploded to $11 billion, and we weren't even going to see the samples until the 2040s. It was becoming clear that our ambitions for Mars were starting to move way faster than our plans. And that's what sparked the major reset of 2026. It all happened so fast. First, Congress basically killed the sample return mission. Then, NASA followed up by canceling its Lunar Gateway space station. Suddenly, the focus wasn't on just orbiting things anymore. It was all about getting boots on the ground. All of that money, all that brainpower, was suddenly aimed at one single massive target, figuring out how to land people on Mars. Okay, so with this new goal locked in, attention turned to the first, and maybe the most obvious hurdle, the journey itself. How do you conquer that mind-boggling emptiness between our world and the next? And what a hurdle it is. We're talking about an average of 225 million kilometers of nothing, just empty space. Crossing that isn't as simple as pointing your ship and hitting the gas. It's one of the gnarliest engineering problems we have ever tried to solve, and it's led to two totally different schools of thought. So it really breaks down into two main philosophies. On one side, you've got NASA's slow and steady approach, nuclear electric propulsion. Think of this like a giant cosmic semi-truck. It uses a fission reactor to create this gentle, continuous push that goes on for months, perfect for hauling tons of cargo. On the other side, you have SpaceX's Starship. This thing is a drag racer. It's all about raw power, these incredibly intense chemical burns that get you there fast. But man, does it drink a staggering amount of fuel? NASA is definitely playing the long game here. Their test flight, the SR-1 Freedom, is slated to launch in 2028. And you have to understand, this is a huge deal. It's going to be the first time in over 60 years that we've used a nuclear fission reactor to propel a spacecraft beyond Earth's orbit. It's a make-or-break test for the very tech they hope will carry the first humans to Mars. Now, SpaceX's plan? It hinges on a totally different kind of massive undertaking. To get just one Starship gassed up in orbit for the trip, it has to rendezvous with a whole fleet of fuel tankers. And how many are we talking about? 12. Just let that sink in. A dozen separate launches from Earth just to get one ship ready to go to Mars. It's an absolutely epic logistical challenge. But you see, getting there is only half the battle. Once you've landed, you're faced with an even bigger problem. You can't just call Earth for a resupply. You have to completely sever that 225 million kilometer supply chain and learn how to survive on your own. And the magic word for all of this is ISRU, which stands for In Situ Resource Utilization. It sounds complicated, but it's a simple, revolutionary idea: living off the land. It's the absolute foundation for any self-sufficient colony, and it just means using what's already on Mars, the atmosphere, the dirt, the ice, to make what you need. It's really like a recipe for Martian survival. Step 1, you make your own air. You can literally pull oxygen atoms right out of the super thin CO2-rich atmosphere. Step 2, you get water. You either drill down to find ice sheets or, get this, you can basically microwave the soil to release trapped water vapor. And then step 3, and this is the real game changer, you combine the hydrogen from that water with more CO2 from the air to create methane. That's rocket fuel for the trip home. And the craziest part, this isn't just some drawing on a whiteboard. It's already been done. A little instrument called MOXIE, bolted to the Perseverance rover, has successfully made 122 grams of breathable, 98% pure oxygen from the Martian air. The proof that this can work is sitting on Mars right now, doing its thing.
And this living off the land idea even applies to building your house. One concept is called the lava hive, where robots would just melt down the Martian soil and 3D print it into these super strong basalt domes. But an even cooler and maybe smarter idea is to just use what nature's already provided, these enormous ancient lava tubes that run under the surface. You just seal off the ends, pump them full of air, and bam, you've got these gigantic, naturally shielded habitats.
And that shielding is absolutely 100% critical, because the moment you step outside that habitat, you are stepping into an environment that is designed to kill you. So let's not beat around the bush. Let me count the ways Mars tries to kill you. Because the threats are relentless, they're invisible, and they are coming at you from all sides. It's really a triple threat. First up, radiation. Mars doesn't have a magnetic field like Earth, so it's just constantly getting hammered by cosmic rays that literally shred your DNA. Second, the low gravity. At just 38% of what you're used to, your muscles and your bones will just waste away. And third, the ground itself is toxic. The dust can scar your lungs, and chemicals in the soil can poison your body from the inside out. But for every single one of those threats, there's a countermeasure in the works. For radiation, you just bury your habitat under a couple meters of Martian soil. For the low gravity, intense, specialized exercise routines to trick your body into staying strong. And for the toxic dust, super advanced air filters, special airlocks for your suit so you never bring dust inside, and even dietary supplements to counteract the chemicals. So look, solving all the engineering problems and all the biological challenges, that's one thing. But surviving on Mars for the long haul brings us to the final and maybe the toughest question of all. Once you've actually built this new world, who's in charge? Who makes the rules? You know, for over half a century, this single line from the Outer Space Treaty of 1967 has been the law of the land. Well, the law of space. It basically says that space belongs to everybody, that it's a global commons. You can't just plant a flag and claim a planet for yourself. And then you have this. A little sentence tucked away in the terms of service for SpaceX's Starlink satellite internet. It directly challenges that entire treaty, saying Mars will be a free planet and that no government on Earth will have any say over what happens there. I mean, wow, this sets up a fundamental clash of civilizations before the first one is even off the ground. And this really gets at the two competing visions for what Mars will be. On one side, you have this common heritage idea. Mars belongs to all of us, and any resources or benefits are shared by all of humanity. But on the other side, you've got a first possession model. Think the American West. The idea is you own what you work. You develop the land, you get the rights, and that becomes the seed for a new, totally independent Martian society. And history gives us a pretty brutal lesson about why this debate is so important. The Jamestown colony. They nearly starved to death under a system where everyone shared everything equally, no matter how hard they worked. It wasn't until John Smith showed up and laid down the law, "Those who do not work shall not eat," that the colony found the motivation to survive. It's a really powerful reminder that on a new frontier, these aren't just abstract legal ideas. They are literally matters of life and death. Which brings us to the final, biggest question of all. We talk about Mars as our backup plan, right? A lifeboat for humanity. But is that all it's going to be? Or are we on the edge of something so much bigger? Not just another human outpost, but the actual birthplace of a new, independent branch of civilization with its own rules, its own culture, and its own destiny out there among the stars. The answer, I guess, is going to be written in the red dust of that next frontier.